Geometric sequences in series. A geometric sequence is a sequence where the ratio between consecutive terms is the same number r. We call that ratio the common ratio. In these next two examples, we want to decide whether the sequence is arithmetic, geometric, or neither. If it's arithmetic, we need to find d, the common difference, and the next term, and if it's geometric, we need to find r, the common ratio, and the next term. So in example 1, from the first to the second term, we actually subtracted 108. And then from the second to the third term, we added 36. So we can tell that this is not arithmetic, just looking at the first three terms. So let's check to see if it is geometric. From 81 to negative 27, we actually divided by negative 3. And then from negative 27 to 9, divided by negative 3, and again, divided by negative 3, and again, divided by negative 3. So if we are dividing by negative 3, this is actually a geometric sequence. However, we always want our r to be in terms of multiplication. So instead of dividing by negative 3, we're going to say we are multiplying by the reciprocal, negative 1/3. So our r is negative 1/3. And if we want to find the next term, we're going to take the last one we have, 1 times our common ratio, negative 1/3, and we will get negative 1/3 as our next term. I want you to go ahead and pause, try example 2, and check back with me when you're finished. Hopefully you found that example 2, the sequence is not arithmetic and it is not geometric. So you would say neither, and that would be your final answer. This is the general formula to find the nth term of a geometric sequence. It is given to us on the SOL formula sheet, so again, you don't have to memorize it, you just need to know how to use it. So a sub n, again, is the nth term. A sub 1 we know is the first term. Now r we defined as the common ratio, and n still stands for the term number. In these next two examples, we need to write the first 4 terms of the geometric sequence, beginning with n equals 1. In example 3, we're given the common ratio and the first term, so we actually need to use the general formula given to us so that we can build a specific formula for this problem. So we start with a sub n is equal to our first term times our common ratio to the n minus 1. Now we're going to go ahead and start substituting in for our n to give us our first 4 terms. So a sub 1 is going to be 2 times 3 to the 1 minus 1, which this is going to simplify to give us a value of 2. A sub 2, we're going to substitute in 2 for n, and this simplifies to give us 6. A sub 3, we substitute in 3 for n, and when we simplify, we get a value of 8. And lastly, a sub 4, we're going to substitute in 4 for n, and when we simplify, we get a value of 54. So the first 4 terms of our sequence are 2, 6, 18, and 54. Now I want you to go ahead and try example 4 on your own and check back with me when you're finished. The only thing you need to keep in mind is that they actually already give you the formula, so you can start really at this step. Hopefully you found your first 4 values to be 4, 8, 16, and 32. If not, pause and check your work with mine and see where you might have made a mistake. In these next 2 examples, we want to write a formula for the nth term, then find a sub 7, which is the 7th term. So given the general formula of the geometric sequence, remember, we really need the information for the first term and the common ratio. In example 5, it's really easy because they give that information to us. So all we need to do to find the formula for the nth term is substitute in those values. So 4 is our first term. Our common ratio is negative 3 to the n minus 1. So this is going to be our first answer, the formula for the nth term. Then we want to go ahead and substitute in 7 for n so that we can find a sub 7. So we're going to substitute in 7 for n to find the 7th term, and when you simplify this, you should get a sub 7 is 2,916. Now I want you to try example 6 on your own and check back with me when you're finished. You just have a little extra work to do to identify the first term and find the common ratio. Hopefully you found that the common ratio was 2 because we're multiplying by 2 to get the next term. The first term is 5, so our general formula is a sub n equals 5 times 2 to the n minus 1, and then a sub 7 equals 320. In this next example, we're given 2 terms of the geometric sequence, and we need to find the common ratio r. So the first thing we're actually going to do is lay out the steps that we have. 1, 2, 3, 4, 5, 6, 7. So I made 7 slots because if we count from the first term, all the way up to the 7th term, we're given that our 4th term is 27 and our 7th term is 729. So following our steps here, number 1, we actually need to assign new values for n temporarily. That means for step 1, we are actually going to make a sub 4 our first term. And then we're going to count, this is going to be our a sub 2, a sub 3, and finally 729 is going to be our a sub 4. What this means is that we are going to let a sub 1 represent 27, and then a sub n, which is our a sub 4, gives us 729. And then our n is going to be equal to 4. So then we're going to take our general formula for the geometric sequence, substitute in the information that we have, and solve for r. So if we take a sub n equal to a sub 1 times r to the n minus 1, and substitute in these temporary values, a sub n is 729, a sub 1 is 27, r is what we're looking for. We said n is going to be 4, and then minus 1. So now it's just a matter of solving this equation for r. So our first step is I'm going to simplify our exponent. 4 minus 1 is going to give us 3. Now, we can't do anything with r cubed yet, so we actually want to divide both sides by 27 so that we can try to isolate r. So on the left side, 729 divided by 27 is 27 is equal to r cubed. Now, if we want to isolate r, we need to cube root both sides so that these will cancel out, and we're left with 3 is equal to r. So we found our common ratio to be 3. Now I want you to walk through the same steps in this example, just like we did, and then check back with me when you're finished. So the first thing you should have done is remember, list out your spaces and fill in the information that we're given. Then we want to renumber from our first term, a sub 1, all the way up to a sub 4. So we're letting a sub 1 equal 24, a sub n equal to a sub 4, our last term, which is 3/8. And then n is going to equal 4. When you substitute in those values and start solving for r, I want to remind you of one thing. When we divide by 24 on both sides, remember, you can't divide fractions again by another number. So dividing 3/8 by 24 is the same as multiplying by the reciprocal. So this is why I have 3/8 times 1 over 24. Then that gives you 3 over 192, which simplifies to 1 over 64. And then when you take the cube root of both sides, you actually get that your common ratio is 1/4. In this next example, we're given 2 terms of the geometric sequence, and we need to find the 12th term. So our first 2 steps are actually exactly what we did in the previous 2 examples. So I want you to pause, try practicing that again, find r, our common ratio, and then check back with me so that we can finish up the rest of this problem. So hopefully you found that the common ratio was equal to 1/2. So that means that as we move each term to the right, we're going to multiply by 1/2. So our very first step actually in part 3 is we're going to need to find a sub 1, our first term. So if we multiply by 1/2 going to the right, we need to do the opposite going to the left so that we can find a sub 2 and then a sub 1. So instead of multiplying by 1/2, we're going to divide by 1/2, which is the same as multiplying by 2. So 20 times 2 is 40. 40 times 2 gives us 80. So what we need is our first term is equal to 80, and then our common ratio is 1/2. So we're going to go ahead and find the formula for the nth term, which is a sub n equals a sub 1 times r to the n minus 1. Here's our formula for the nth term. Now our last step is to find the 12th term. So we're going to find a sub 12 by substituting in 12 for n. And then when you simplify this, we're going to get a sub 12 is equal to 5 over 128. I want you to go ahead and try example 10 on your own. Again, walk through step by step just like we did the previous example, and then check back with me when you're finished. So hopefully you found your common ratio to be 1.5, and then you use that to go backwards and find that your first term was 4. Then you took your first term and your common ratio, substituted it in to get your formula for the nth term, then substituted n equals 7 to find that a sub 7, the 7th term, is 45.56. If you didn't get that, pause, check your work with mine, and see where you might have made a mistake. The geometric series is the sum of the first n terms for a given geometric sequence. So this is the formula we're going to use. The sum of the first n terms is equal to the first term times 1 minus the common ratio to the term number over 1 minus the common ratio, where the common ratio is not equal to 1. So again, this formula is given to us on the SOL formula sheet, so you don't need to memorize it, you just need to know how to use it. So let's go ahead and look at this first example. We need to find the formula for the nth term of the geometric series and then answer part B. So for our formula, we know that our first term is 1, and we need to find our common ratio. Don't be thrown off by the plus signs. That means we're just going to be adding all those terms for the series. Our ratio from 1 to 9, we multiplied by 9. 9 to 81 multiplied by 9, and 81 to 729 we multiplied by 9. So if we know that our first term is 1 and our common ratio is 9, then we can go ahead and substitute those values into the general formula for a geometric sequence. So then we'll have a sub n is equal to 1 times 9 to the n minus 1. Now, this isn't incorrect, but since our first term is 1, you can actually rewrite that as 9 to the n minus 1, because multiplying by 1 isn't going to change our value. Then, for part B, it wants us to write the formula to find the sum of the first 8 terms. So we're going to take this formula, the sum of the first 8 terms, and then substitute in our values. Our first term is 1, and then we're going to substitute in our ratio for 9, and we want n8 because we want to find the first 8 terms, and then 1 minus r on the bottom. So after we substitute in these values, we need to actually find the sum. So we're going to simplify all of this, and we are going to get a sum of 5380840. So this is the sum of the first 8 terms of this geometric sequence. I want you to go ahead and follow the previous example we just did, work out this one, and check back with me when you're finished. Hopefully you found that the general formula for the nth term is a sub n equals 3 times 1.5 to the n minus 1, and also that the sum of the first 10 terms is 339.99. If that's not what you got, pause, check your work with mine, and see where you might have made a mistake. That's it for this set of notes on geometric sequences and series.